In this exercise, we are to graph the equation y squared minus 6y minus 4x plus 5 is equal to 0. This is an equation of a parabola since the y variable is squared and x is in the first power. This is general equation of a parabola. So before we graph, we'll write this equation in a standard form. The first thing in this process is to isolate the terms with the y squared, in this case, on the right, and the x terms and the number on the other side. We'll complete the square on the left-hand side of this equation. And to complete that square, we'll have to take the number 6, divide by 2, that gives me 3, and the square of the 3, which gives 9, and this is the number that will be added to both sides of that equation. With that number chosen, the left-hand side becomes y minus 3 squared, and the right-hand side will be 4x plus 4. After factoring 4 coefficient of x from on the right-hand side, we'll get the standard equation of that parabola, which will allow us to determine the vertex. Vertex is at the point -1 because we have x plus 1, and 3 because we have y minus 3. So this is the vertex. Now we need to graph that parabola. So we'll start with plotting the point -1 and 3. This is my vertex. I will draw the graph using the second method of translating the coordinate system rather than a parabola. So I will draw a coordinate system going through the vertex with axis parallel to the original axis and with the origin at the vertex. And in this new coordinate system, I will graph the parabola that is obtained without the shifts. So this parabola is going to be y squared. We omit minus 3 from the formula, equals 4x. That means that this is the parabola that will open to the right, and 4a in the general formula will have to be 4, so the value of a is equal 1. So that gives me the position of the focus. Focus is on the new x-axis, 1 unit away from the vertex. So here is the position of the focus. Once we have the focus, we'll use the latus rectum segment to graph the parabola. Since the distance between the vertex and focus is 1, to get to the latus rectum endpoints, we'll have to start with the focus and go 2 units up and 2 units down. We go perpendicularly to the axis of symmetry, and therefore the graph of this parabola can be now drawn. We also have to identify the directrix, and the directrix is on the opposite side of the vertex, the same amount away as the focus. So we'll start with the vertex and we move 1 unit away because that's the distance between vertex and the focus, and draw the line that is perpendicular to the axis of symmetry. So we obtain the line y equals -2. And therefore, we can say that for this parabola, vertex is at the point -1 and 3. The focus is at the point 0 and 3. And the directrix has the equation x equals -2. You have to remember that those coordinates are read as the coordinates in the original graph, not in the helper graph that we only drew to make the graphing of the parabola easy.